So we are now on to dividing fractions. You have your I can statements. You should be able to answer I can multiply fractions. We're going to go over identifying the parts of the division problem. Know how to make a whole number into fractions. We're going to learn how to check our division with multiplication. Yes, we've got more models. Got more word problems. And one thing we're supposed to be able to do by the end of this is make our own division problem. Now this you won't be tested over, but we will review it in class. Okay. This is what we do to solve division of fractions. Now the one good thing with division of fractions, no mixed numbers. They're going to be a unit fraction, so there's always going to be a 1 on top. And the other number is always going to be a whole number. So you have to know to put a 1 under a whole number. All right? 2 over 1 is the same as 2. 2 is the same as 2 over 1. All right? That's something you will have to be able to recognize right off the bat. Now, the unit fraction could be on either side. The whole number could be on either side. But either way, you make them both into fractions, and then 3 magic words. Keep, change, flip. You keep the first number. You change the division sign into multiplication, and then you flip the last number. So 2 over 1 turns into 1 over 2. This is called the reciprocal. All right? And then after you did the keep, change, and flip, you multiply straight across like you do with multiplication. So that is how you multiply. To check, I've got a little saying down here. Division with multiplication, checking division with multiplication, is using the inverse operation. Very important vocabulary right there. Inverse operation. So this is how I remember it, because it kind of rhymes a little. Which is the reverse. Get it? Inverse, reverse. So it is backwards. All right? So if this is the problem, 1/3 divided by 2, like we did up on top. The very first one, 1/3 divided by 2. And we figured out it equaled 1 over 6. Then we just write it backwards. 1 over 6, 2, 1 over 3. We literally write the original division problem backwards. And then we just put a times and an equals in. That is checking it. That is the problem we use to check it. All right. If you look, there's a 1/6 on both sides. There's a 2 on both sides. There's a 1/3 on both sides. All right. And it is the original problem. Now, could we solve this? Sure. And then that would actually be the process of checking. Okay, so this is just more inverse operations. So if we have a 1/3, a 4, and a 1/12, it is backwards. 1/12, 4, 3. On this, if you notice, the middle number always stays the middle number. It's just these two that switch. So on this one, I would put 1/10 here, and I would put 1/5 here. Right? Middle number always stays the middle number. Fractions and models. Okay, so this is one whole, and it's divided into 3. Well, this is one whole, so this is a half. See how I've got it darkened around it? This is 1/2 divided into 3, so you divide 1/2 into 3 pieces. Well, since it's 1/2, you kind of got to know what the whole is. So there would be 6 of them total for a whole, but it's 1/6. All right, so 1/2 is shaded in of the whole, and then 1/6 is the size you would get. Again, since we got 3 wholes and they're labeled wholes, or you can draw them separated, and they're each divided into half, and then you would just count them. You have 1, 2, 3, 4, 5, 6 halves. Okay. So it is just actually drawing the size you need and then physically dividing it into whatever it says. So we'll go into more. To me, drawing these models are a little more self-explanatory because you're literally just drawing what it says, like you draw 2 and then you divide it into thirds. All right. Or on this one, you draw a third and you divide it in 2. All right. So that is how you draw these models. Very self-explanatory. Now this page you have as a Google form as an assignment. You're going to work as much as you can today, and then you're going to finish it on the next school day. And I at least want you to get through 8 today, number 8. So good luck and happy math.